First of all, allow the test tube of total mass m floats in water and is at equilibrium when it's a distance d submerged as shown. Okay, that's grand. So what's going to happen next is, as shown, the upper force exerted by the water on the test tube is F. Given that F is directly proportional to the submerged length. Now this is very important. The language here, it's very physicsy, okay? Directly proportional to submerged length means the following. You do this in physics all the time. F is proportional to D. F therefore equals KD. Okay? And find the constant proportionality in terms of D, M and G. This could not be any easier. Buoyancy force up equals weight going downwards. What goes up equals what goes down, because it's that equilibrium. Okay? So all you have to say is buoyancy force, or B equals mg, and then B in turn equals KD equals mg, K therefore equals mg over D. That was going for 5 marks that year, and that was much easier than anything we've done. Okay, so there's our first part done there. Handy enough. Now, next part after that is the tube is now pushed down a small amount. I'm going to use a dotted line to represent the old displacement compared to the new. So you push it down, and we're going to call this a displacement x. Is that alright? So what goes up equals what goes down. Your whole goal of this question is show that it will do simple harmonic motion. You are trying to set up A equals minus omega squared x. To do this, you go through force. Force equals ma. Now, to set this up properly, we need the bigger force minus the smaller force minus the bigger force to set up a negative, because it has to be negative, okay? So at the moment when I drag it down, which is bigger, the buoyancy or the weight? Buoyancy is bigger. So that means I'm going to do weight minus buoyancy. I'm going to do mg down that way, and then I'm going to minus now k times what's our new depth? Our new depth below water, d plus x, isn't it? Now I have mg minus kd minus kx. Is there anything that will cancel here? Look at it here, guys. KD equals mg. And look at this, very handy now, okay? A equals minus k, ma equals minus kx. Just get rid of the m and bring it underneath, and you've basically proved that it does simple harmonic motion. Why is a simple harmonic motion? Can anybody tell me? Acceleration and displacement are opposite in sign. Acceleration is negative compared to displacement. It's the two green dots that are the important part. Okay. Now that we've done that, what do we do next? Done. Show that oscillate with simple harmonic motion. Done. Find the periodic time. Oh, that's easy. T equals 2 pi over omega, and T will equal A equals minus omega squared x. This means omega squared equals k over m. This in turn will mean omega equals the square root of k over m. 1 over omega would be the upside down version of that, wouldn't it? It'd be m over k. So look at this. Periodic time is 2 pi over omega. Technically speaking, 2 pi times 1 over omega. 1 over omega is 2 pi root m over k. I'd imagine you get full marks there, okay? But there's one thing that we never really have in the periodic time. We never really have mass there. So what they did in the solutions was they would have isolated mass by saying mass equals kd over g. So they would have changed that into 2 pi over m all over oh sorry, not that, kd over g all over k. The k's cancel, and it's going to be 2 pi root d over g. Usually periodic time has length and gravity, rarely mass is ever in there. That took me all of 5. Remember, I might as well do it. What happens if I do this? Vertical circle, vertical motion question. Straight away, without thinking. Conservation of energy, followed by set your pedal. Now, you can pick a reference point. I can pick a reference point at the bottom of the circle, but the whole point is that they're both, if it's about relative height. I'm not going to go underneath the diameter, am I? I'm going to fall off before I go underneath the diameter. This means you're safe to bring up your reference point to halfway, and it makes the maths a little less tricky. Okay, this reference point refers to potential energy equals 0, and refers to your height equaling 0, height above ground. Okay, so to work the conservation of energy, we have PE1 plus KE1 equals PE2 plus KE2. Now, I have to find the height above the ground. The radius is 7, isn't it? If that's 7, what's this here? What's this red distance here? 7 cos 22. Everybody right with that? So that's your height above ground. So your potential energy at the start is mgh, but in my case it's going to be mg7 cos 22. Is that alright? Now, plus your kinetic energy at the start, a half mv squared. What's v squared at the beginning? We're moving it with 8. So a half m8 squared equals. Now, rub out all this from earlier. I now have to work on this distance here. That black distance there is what I'm interested in. So how do I get that? Anybody tell me? 7 cos alpha. Just 7 cos alpha is my end height above ground. So potential energy 2 is mg times your height off the ground, which is going to be 7 cos alpha. And then our KE2 is going to be, how fast are we at the end of this whole question? Plus a half mv squared. I'm going to get rid of the m's. I'm going to multiply everything by 2. 2g. I had to find out what 7 cos 22 is. Yeah, I'll do that in a second. Okay, I got to double all my answers this time now. That's going to be 64, isn't it? And this one here is, oh yeah, multiplying by 2 both sides. That's alright. Phi squared over here, and then I'm going to multiply that by, that's going to be 14g cos alpha. Okay guys, I'm going to turn all the g's into 9.8 for a minute, just because it's not compatible with the 64 anyway, so I might as well have decimals. So I think that one is going to, just somebody check this out for me, because I have an ever so slightly different solution. 127.2. So 19.6 multiplied with 7 cos 22. Is that alright? And then the other one, I think is just looking at 14 multiplied by 9.8. I think I'm going for 137.2. Okay. Okay, add the two of them together, I get 191.2 minus my 137.2 cos alpha equals my phi squared. Okay, some of you might ask me why would you bother isolating the v squared. We're going to see when we use the central pedal force that's going to happen. Okay, so when you're talking about centripetal acceleration, you had a choice of which formula to use. We have centripetal acceleration, or sorry, centripetal force even. Centripetal force could be mv squared over r, or it could be mr omega squared. Why did I not choose mr omega squared? What stopped me from that choice? Velocity. They gave me in terms of v, not in terms of omega. Okay, so that determined my choice there. So what we're going to do next is FC, which is MA. MA, or sorry, centripetal force, excuse me. I actually had to figure out how I get this force, is what I have to figure out. So what I often make the mistake still to this day is when I work on the centripetal force equation, please remember you're talking about the velocity at the end of the question, not at the start. If I'm on a bad day, you'll find me working over here, breaking the components down, working on completely the wrong area. Okay? On a good day, 9 times out of 10 hopefully, is I'm over here working on the correct part. So what you need to do is this. You have two things. You make a triangle for the weight acting directly down, directly across. So you have to resolve your weight parallel and perpendicular to the radius at the point you're talking about. Parallel to this radius here is what I'm looking for. Parallel and perpendicular. I then go through a series of alternate angles. Alpha, alpha, and then alpha here. Everybody right with that? Then once I do that, that's mg. This makes this mg cos alpha going this way, and mg sine alpha going this way here. Centripetal force is in two different parts. You have your r value that's supporting you outwards, and you have your mg cos alpha that's dragging you back in. Now please remember, what way is centripetal acceleration directed? Is it directed towards the center of the circle or away? It's directed towards the center of the circle. That means the mg cos alpha is considered positive, while the r, which is going in the opposite direction, is considered negative. Does that make sense? One one's considered positive, the other one's considered negative. Then we're going to get mv squared over r, which is going to be mv squared all over 7. Got to multiply both sides by 7. 7 mg cos alpha minus 7r equals mv squared. Skier loses contact. What does that mean? R equals 0. So now we're going to have phi squared equals 7g cos alpha. Change the g into 9.8. 7 times 9.8, anybody? 68.6. Let you work it out for a minute, you tell me. 7 times 9.8. I'm going for 68.6 anyway. Yeah. Now I have two very compatible looking equations. So I have 191.2 minus 137.2 cos alpha equals 68.6 cos alpha. Now, does answering alpha actually get me the answer to my question? Find the value of alpha. Perfect. It actually does, for once. So take them away from me, bring them over, add them together. We get 205.8 cos alpha equals 191.2. Bring it underneath, cos inverse. Oh wait a second. That's 205.8. And then cos inverse that, and you're going to get alpha equals 21.7 degrees. That one